What is engineering?
Noun, the branch of science and technology, including the activity of applying scientific knowledge to the design, building and control of machines, roads, bridges and electrical equipment.
Engineering, from the Latin ingenium, meaning cleverness, and ingeniare, meaning to contrive or devise.
So engineering is a form of problem solving or of being able to improve mechanisms. So whether it is trying to come up with a better way of taking videos or a better way of building bridges, or to solve a problem that doesn't actually have any solution yet.
Engineering is a form of problem solving where you look for a solution to a mechanical or a civil engineering issue. For instance, building a building, building a bridge, or creating vehicles, rockets, so on. Engineering is also used to make things more efficient.
Here are 5 different examples of types of engineering. Chemical. Molecular, which focuses on the manufacturing of molecules. Process, which focuses on the design, operation, control and optimization of chemical processes. Civil. Transport, which uses engineering to ensure safe and efficient transportation of people and goods. Structural, the engineering of structures that support or resist structural loads. Electrical. Computer, the design and control of computing devices with the application of electrical systems. Optical, the design of instruments and systems that utilize the properties of electromagnetic radiation. Mechanical. Thermal, concerns heating or cooling of processes, equipment, or enclosed environments. Vehicle, the design, manufacture, and operation of the systems and equipment that propel and control vehicles. Systems. Aerospace, the application of engineering principles to aerospace systems such as aircraft, spacecraft, and ground control systems. Formerly known as aeronautical engineering, concerns the design, construction, and science of both air and space vehicles, primarily on the systems level. Mechatronics, a hybrid of mechanical and electrical engineering commonly intended to examine the design of automation systems.
What was engineering?
Origin of engineering in ancient Egypt. The Egyptians invented and used many simple machines, such as the ramp and the lever, to aid construction processes. The earliest civil engineer known by name is Imhotep. As one of the officials of the pharaoh Djoser, he probably designed and supervised the construction of the Pyramid of Djoser, a step pyramid, at Saqqara in Egypt around 2630 to 2611 BC. He may also have been responsible for the first known use of columns in architecture. Levelling. The Egyptians had levelled the area intended for the Great Pyramid by cutting a grid of shallow trenches into the bedrock, flooding them with water and reducing the intervening islands of stone to the necessary height. Ramps. A system of ramps must have been used to drag the millions of blocks into their positions in the various pyramids.
Aztecs. The capital city of the Aztecs, Tenochtitlan, was an engineering masterpiece. Aqueducts and canals snaked through the city, channeling pure water to possibly 200,000 inhabitants each day. They built their capital in the most unlikely of places, the centre of a lake. Tenochtitlan was a city surrounded by water, with temples and pyramids, sparkling white monuments and ceremonial squares. The climate in this region of the Aztec Empire was very hot and humid. The Aztecs kept their city clean by keeping the canals full of fresh water, which came from the mountain springs. In periods of low rain and water, the city of Tenochtitlan would ask neighbouring city-states to open their canals and let fresh water flow. Aztec skill in engineering was evident in the fortifications of their island capital. The Aztecs further developed sculpture, weaving, metalwork, ornamentation, music, and picture writing for historical records. Agriculture was well advanced and trade flourished.
Roman engineering. The Romans put a great deal of effort into engineering. Roman engineering led to the building of some remarkable engineering feats that have survived to this day throughout Western Europe. Be they roads, theatres, baths, or Hadrian's Wall. Engineering was used as a way of improving the lifestyle of the Romans, even on day-to-day issues such as a frequent water supply. The Romans used the ideas of the ancient Greeks to implement their own engineering plans. The whole issue of supplying Rome with water was solved using a system of 640 kilometers of aqueducts. The aqueduct at Segovia in Spain is 60 meters high in places. The fact that it survived so long and in its current condition is testament to the engineering skills of the Romans. Another classic example of Rome's engineering skill has to be the numerous Roman roads that still exist all over Western Europe. A Renaissance engineer. Integrated engineering trains students in a wide range of fundamentals, making them particularly attractive to small and medium-sized companies.
The Middle Ages. After the fall of the Roman Empire, progress in European bridge building slowed considerably until the Renaissance. Fine bridges sporadically appeared. Medieval bridges are particularly noted for the ogival or pointed arch. The most famous bridge of that age was Old London Bridge, begun in the late 12th century under the direction of priest Peter of Colchurch and completed in 1209, 4 years after his death.
The Industrial Revolution occupied the 18th and 19th centuries. It was a time of sweeping technological changes, most of them developed by engineers. A primary aspect of the Industrial Revolution is that machine power replaced human and animal power. For example, steam engines were developed to pump water from mines, replacing human or animal-powered pumps. Also, during the Industrial Revolution, the field of engineering continued a transition from application of rules of thumb to application of the growing body of knowledge of science and maths. During the Industrial Revolution, familiar engineering disciplines, particularly civil engineering and mechanical engineering, began to emerge as identifiable specialisation. There were many technical advances made during the Industrial Revolution. We briefly consider 5 advances in this section. The development of an accurate clock to measure longitude, steam engines, automatic machinery for creating textiles, mechanical printing, and steam-powered transportation. While there were many other technical advances during the Industrial Revolution, these give an overview of the different processes and technologies that became important in this era.
Ancient Greek engineering. Ancient Greek technology developed during the 5th century BC, continuing up to and including the Roman period and beyond. Inventions that are credited to the ancient Greeks include the gear, screw, rotary mills, screw press, bronze casting techniques, water clock, water organ, torsion catapult, the use of steam to operate some experimental machines and toys, and a chart to find prime numbers. Many of these inventions occurred late in the Greek period, often inspired by the need to improve weapons and tactics in war. However, peaceful uses are shown by their early development of the watermill, a device which pointed to further exploitation on a large scale under the Romans.
What will engineering become?
Engineering in all forms will continue to develop into the future. Professor Hawking says the primitive forms of artificial intelligence developed so far have already proved very useful, but he fears the consequences of creating something that can match or surpass humans. He says that the development of full artificial intelligence could spell the end of the human race. The theoretical physicist who has the motor neuron disease, amyotrophic lateral sclerosis, is using a system developed by Intel to speak. This is an example of computer engineering. This shows the widespread effects of engineering.
Engineering is crucial to human progress. Engineering is about the practical delivery of scientifically informed solutions for the great challenges and opportunities of a rapidly evolving world. Engineers take scientific discoveries and apply them practically. Their work literally creates the fabric of society, whether the buildings we live and work in, the energy that powers our world, or the transport networks that we use every day. Engineering is so diverse, it is sometimes hard for the public to see a common thread between its feats. At one end of the scale, engineers are responsible for the massive scale design and build of the Large Hadron Collider, and at the other, to the many applications of nanotechnology. Engineering creates the breathtaking yet sustainable new buildings on the skylines of the world's greatest cities, as well as bringing clean water and sanitation to remote, impoverished villages. Then there is communications, creating a growing sense of world community, enabling billions of people to access information and services and new opportunities. The bedrock of engineering is the application of mathematical and physical theory. But engineering is far more than just about knowledge. An engineer's core business is to turn theory into practice.
Engineering is infinite.
Engineering is
Everything!